We are going to discuss about schematic eye. So what do we mean by schematic eye? So it's schematic eye is simple mathematical or physical model that represents the basis of optical feature of real eye. Okay, it is a basis of optical feature of real eye. It's actually mathematical or physical model. So schematic eye is a theoretical optical specification of idealized eye and retaining average dimensions but omitting complications. What do you mean by that? So in case of schematic eye, we try to take care of dimensions, which is original dimensions of eye or approximation dimension of eye, but we definitely try to omitting the complications of actual eye. So one of the complications that we try to omitting is refractive index. Definitely refractive index of lens is graded, like it's from moving from cortex to nucleus, refractive index increases. It's not direct case that nucleus is that much of refractive index, for example 1.41 and cortex is 1.39. It's not that simple. And another complications we try to omitting is surface, that four surfaces, at least refracting surfaces, are aspheric, not spherical. So we try to omitting that complications too. So nowadays the new form of schematic eye try to address that thing too, but it's quite complicated. So objective schematic eye is provide the basis for theoretical studies of eye as an optical instrument. That's the great point that as an optometry student you have to understand. So schematic eye is the only one field that got Nobel Prize till now. So Goldstein got Nobel Prize in 1901 or I don't know, and he got the Nobel Prize for his invention of schematic eye, not for invention of slit lamp. So you must understand the only thing that got Nobel Prize in ophthalmology is schematic eye. Okay, so because you made the schematic eye, and schematic eye helps in theoretical studies of eye as an optical instrument. We can study eye as an optical instrument. Okay, so classification of the schematic eye is paraxial schematic eye. I have discussed about it in previous video. That is paraxial means what? Paraxial assumption means what? Paraxial schematic eye, that basically paraxial means we use spherical surfaces. Okay, and we consider sin theta is equal to theta when theta is radiant. When theta is radiant, and we consider that. Okay, fine. So okay, so another is finite or wide eye schematic eye. So in case of paraxial schematic eye, there's three things: exact eye model, simplified eye model, and reduced eye model. And many of my previous video I used reduced eye schematic eye model. And what is the difference between exact eye model, simplified eye schematic eye, and reduced schematic eye? That's also the question. Okay, let's talk about exact eye. So surface radii of curvature, surface separation, and refractive indexes of exact eye closely match to the real eye value. So in case of exact eye, we try to match surface radius, surface separation, and refractive indices closely. So which means two corneal surface, two lens surface, anterior posterior, isn't it? So schematic eye that falls under the category of exact eye is Goldstein exact eye and Legrand full theoretical eye, isn't it? So see, this picture is most central picture, but in this picture too there is a four surfaces, isn't it? In case of lens there is four surfaces. Actually it should be two, because we don't treat lens as a cortex and nucleus, but in this picture it's considered lens as a cortex and nucleus. See, front surface of cornea given the power radius of curvature 7.7 and back surface 6.8. Whenever your teacher asks what is the radius of curvature of front surface of the cornea, then you will answer 7.7, isn't it? Because 7.7 is given by Goldstein, which is taken as a standard. And whenever teacher or any viva people ask what is the back surface of the cornea and radius of curvature, you will definitely do 6.8. And why? Because Goldstein. And refractive index of the cornea 1.376. Why? Because of the Goldstein standard. So this is very important. Refractive index of aqueous, refractive index of C 1.406, and refractive index of cortex radius of curvature of nucleus, radius of curvature of back cortex, isn't it? It's very important. See, this is posterior focal point, this is anterior focal point, why it is max minus in opposite direction of light. So you can understand this. This is principal point, primary and secondary. This is entrance pupil and exit pupil. So and this is nodal point, primary and secondary. So this is optical axis, isn't it? So distance between cornea and lens, distance of lens, isn't it? That's all things consider. See, it's all things. It's very important to know everything, every digit and position of even primary focal point, primary principal point, secondary principal point, and entrance pupil, exit pupil, nodal point, primary nodal point, secondary nodal point is centrally important. And refractive indices, according to Goldstein, exact eye for the relaxed vision. Obviously, it's for relaxed vision. In accommodation, there is different thing. So you must read all the point and all the curvatures, which is very important whenever in viva or in actual life. Okay, so these are the actually parameters of simplified Goldstein eye relaxed model when accommodation is 0 and when accommodation is 8.599. So this is accommodated state and this is relaxed state. So what is the important point? See, primary focal point in minus, secondary focal point. So location of object side nodal point, image size nodal point is secondary nodal point, principal plane, image size, entrance pupil, isn't it? Diameter of entrance pupil. So it's very important. Corneal power and lens power, total axial length. So it's always important, these small things. See the different parameter of Goldstein eye model. You can see front surface of Goldstein, back surface of Goldstein. Can you see front surface of cornea? Sorry, lens, cortex. So there are a lot of things in accommodation, in relaxation. Please pause the video and see all the things. Okay. So simplified schematic eye, the cornea is reduced to single surface, refracting surface. Simplified means, isn't it? In the previous real eye, there are two surfaces, front and back. But in case of simplified, cornea is from two surface to one surface, and it has lens of two surfaces. Lens is considered as two surfaces, and single uniform. What do you call this? I don't know. Wait, single. So corneal radius, when reduced to single surface, then corneal radius is slightly smaller than the real eye. So example of real eye is Goldstein version 2, schematic eye is an example of real eye. So this is the picture. So two surfaces of cornea and lens and one surface of the cornea. So you can see the different parameters. Okay, so let's come to the reduced schematic eye. Reduced schematic eye is a lot of time used in uh, discussing simple concepts in optometry and vision science, and obviously it consists of single convex surface separating from air to medium of refractive index and is similar to the vitreous body, and lens is completely neglected. So cornea only, and the cornea is only surface refracting. So it means the refracting power resides in only one surface. There is no four surface, there is no two surface or three surface, only one surface. So reduced eye cannot be used to study Purkinje image, because in Purkinje image we need four surfaces, isn't it? First Purkinje image, second Purkinje image, third Purkinje image, fourth Purkinje image. But in case of schematic, in case of reduced schematic eye, we cannot use this reduced schematic eye for studying of Purkinje image. So it's simple. Only one refracting medium and only refractive index, and just simple focal length and power. Okay. So reduced model as listings reduced model and Emsley reduced model and Donner's reduced model. There is a difference obviously between them. Listings reduced model. This is picture. Pause and see. And see here we can see very few things that are important and difference basically. The principal point in listings model is 1.5 mm and it's in 2 mm behind that, but Emsley is exactly at the cornea. Nodal point distance is different, isn't it? And primary focal point distance is different. Secondary focal point distance is almost same but different. In refractive index in almost all cases is same. Radius of equivalent is same. Sometimes you can see the nodal point and the radius of curvature is same in case of Imsley. So there are few subtle differences, but it's not the thing that you have to just remember all these things. But understand, if we call reduced schematic eye, it means only one surface that has power. That's front surface of the cornea, or whatever you want to tell. So it's a comparison of Goldstein Imsley schematic eye with a reduced eye. So this is the lower portion is all reduced eye parameter, and this is Goldstein schematic eye. Just pause the video and see all these things, okay? And when compare things. So finite schematic eye, which is nowadays concept, they are regarded as improved paraxial schematic eye because I'll tell you why it is improved. Should be asphericized surface. So surface are primarily we used spherical surface. Now it's asphericized surface, and refractive index is gradient. That change in refractive index, and curved retina. Retina two, we tell the retina two is curved and all these things. The two example of finite is Navarro eye model and Leo Baronet eye model. So you can see in these pictures too, isn't it? Cornea is centrally thin and peripherally thick, and all these things. So in parameters like this, so you can tell this parameter, isn't it? Relaxed version and this version in Novaro, and this is the parameters they used. So you can see and pause the video and see. Okay, applications. What are the applications of schematic eye? Design of correct glasses and contact lenses, obviously, to use uh, study of correct glasses and contact lenses in eye. So design and layout of optical imaging system in visual aids, because whenever we are trying to uh, do the visual aids, so like intraocular lens calculation, then we can obviously think about schematic eye and putting uh, IL in schematic eye and study the image features formed in retina. And design and layout diagnostic device, definitely. And simulation and planning of surgeries for treatment of eye disease and refractive errors, isn't it? It's very important to have optical model for doing all these things, and calculation of derived eye parameters is all things we use schematic eye. So that's why schematic eye is centrally important. So limitation of schematic eye: construction with rotationally symmetrical surface, because we know that we don't have rotationally symmetrical surface in real eye. So but we have to construct uh, all the surfaces rotationally symmetrical. That's also limitation. And refractive index assumed to be constant. So we don't have refractive index assumed to be constant. Suppose lens has refractive index gradiently increases in nucleus and gradiently decreases towards cortex, but we cannot do that, and we are not doing that. And phobia is assumed to be in optical axis. That's always impossible in case of the eye. Phobia is never in uh, optical axis, but it in visual axis. So visual axis and optical axis coincide, but actually in actual eye, it's never happened. Very poor predictor of monocular aberration, because we consider everything as our desired. Monocular aberration is very poorly predicted, but in actual eye there is a aberrations component. So it's quite difficult to study aberration in schematic eye too. So that's the limitations. In summary, schematic eye provide the basis for theoretical study of the eyes and optical instrument. Schematic eye model are used to derive the standard optical property like refractive power and image behavior and position of cardinal points and influence of aberration and so on. So we study actually a model. Schematic eye is a model for studying eyes optical behavior. So different model have different parameters and use. They have eventually got better with the time. Yes, definitely. So in later on we discuss about Novara where aspheric surface are uses. So there are a lot of things that's improved time and time. Okay, so in this presentation I use specifically these three books. We have discussed about Michael P. Keating, and these are the great books for studying schematic eye. For till now, choose. Bye.